Welcome to the radiomics machine learning tutorial, where you'll delve into training models on radiomics features, testing, and analyzing them. Assuming you've gone through our previous tutorials and are familiar with the interface, let's get started. Begin by configuring your experiment using the available nodes. Each node represents a distinct process, such as the cleaning node for removing irrelevant features. Comprehensive details can be found in our documentation. For every experiment, start with the split node to create your test train splits. Specify your outcome name, activate or deactivate the switch to create a holdout set, select your dataset outcomes file, and designate the folder for saving your experiment results. Next, add the design node to structure your experiment. This includes defining the experiment name for identification, selecting the split type, random or institution-based, determining the number of splits, opting to flag by institution to ensure an equal number of institutions in the test and train sets, specifying your test/train proportion, and setting your random seed for regeneration purposes. The third step involves loading your data using the data node. Ensure the name type remains as radiomics for radiomics studies. After loading the features folder, the node will detect and display all CSV files in your directory, allowing you to select the ones to use for the experiment. Proceed to the fourth step, cleaning your data, which is strongly recommended though not mandatory. Input parameters include the missing cutoff per sample, missing patients cutoff, minimum variation, and selecting an imputation method to replace missing features. Next, normalize your features in the fifth step to mitigate batch effects caused by institutional diversity. Currently, only the combat method is available for normalization. In the sixth step, reduce your feature set using false discovery avoidance method to eliminate unstable and intercorrelated features. All inputs are thoroughly explained in the methods article. Moving on, configure your learner for model training. Currently, only the XGBoost algorithm is available. Specify the variable importance threshold to eliminate features with low importance. You can also customize your model's threshold. Select your model's save name, optimization metric, valid only when using Picaret, set your model's training method, automatic for Picaret, manual optimization for others, and set your seed consistently. Finally, define your analysis method, selecting the desired methods and setting their options according to your preferences. Refer to the MEDiml documentation for further details on each method. Once your experiment setup is complete, it's time to execute it. Click the Run button located in the top right corner. A progress bar will appear, displaying the current split number and the ongoing experiment. Once the experiment concludes, the Show Results button will be activated automatically. Click on it to view the experiment results. Navigate to your experiment name to access the model metrics, and explore the generated plots below. Enable the Compare mode to compare results from different experiments. This feature is showcased in the renal cell carcinoma demo. Finally, use the Generate button to generate Python code for your experiment. Isn't that cool? Once the Python notebook is generated, it will promptly open, providing you with the Python code for the selected experiment. Feel free to manipulate the code as needed, and we look forward to seeing you in the renal cell carcinoma demo.